I've seen this, but it's like really funny considering it's like
I have a quick question. So I use the math tutorial to have GIF, but I only got wait, I'm not sure, is that working?
Yeah, it should work.
Oh, okay.
Yeah, when you put it into Discord, it will autoplay.
Oh, okay.
So, let's see. What did you make that for? Homework 4?
Homework 3.
Or 3? Okay. So.
It's not working?
Here it is.
Oh, it's working.
Yeah.
Wait, but I don't know why it's dark. Because I don't have the sound.
Yeah, maybe. That could be the case. It also depends on what kind of material you use to yeah. But this is fine. I think it's good. You could use emission, but that will completely eliminate any sort of lighting from your body. So, experiment, play around. It's good though. Okay, ladies, gentlemen, everyone, good to see you. We are back for 298, and this is actually going to be a bit of a short lecture today. We must be out of here by 3 p.m., okay? And by out of here, I mean, you can probably stay right there. I just need to get off the podium, okay? So we'll definitely be done by that time. I've got some announcements for you. The first computer graphics model and animation in history. What was it? I bet it was a really cool fight or a awesome dragon or maybe something a little bit more humble. As you watch this video, take note of how good we have it today. Okay? Just how good we have it. Let's take a look at what it was like to make the world's first CG model.
Computers features this little animation on most screens. It was created by Ant Campbell and his classmate Fred Park in 1972 as part of their postgraduate course in computer science, and it is widely considered to be the first piece of computer-generated 3D animation ever. It's kind of astonishing to think that in less than 10 years we went from this to this. I don't think it's an exaggeration to say that the research paper that spawned this little video kind of changed everything. Computer animation was sort of on the lunatic fringe at that time, said Fred Park, a fellow PhD student in Campbell's class also worked on animation. People were just barely to the point where they could get a computer to put out still images. It was obvious that it would take years for the state-of-the-art computer hardware to catch up with this ambition, and there was no end of problems to be solved on the mathematical and programming side. Nonetheless, from Campbell's point of view, there was no better time or place to get started than right here and now. In 1972, 3D modeling software obviously didn't exist. So, in order to create the 3D model, a mold of its hand was cast out of plaster. The surface of it was coated in latex. 350 polygons were meticulously drawn onto it. If this thing still existed, it would be in a museum. But according to Campbell,
unfortunately, the hand hasn't survived. Part of it was because over time latex turned into a goo. Although I wish I'd actually cleaned it off and kept the hand.
Every single point of every polygon had to be mapped out before it could be rendered in 3D. This machine that Ed is using in the video was a mechanical digitizer, which provided a readout of each X, Y, and Z coordinate as three distinct numbers, which were captured with
a mouse.
For some perspective, according to Campbell's research paper, this entire hand was covered in 350 total polygons, and each polygon had 3 vertices minimum for max. There ended up being 270 intersecting corners, times 3 coordinates. That's 810 data points to keep track of. For those unfamiliar with 3D modeling terms, I'll use the default cube in Blender as a reference. This point here is a vertex. It's where 2 edges are the lines that make a polygon intersect. A polygon is a flat surface composed of edges and vertices that join together. So the base of this cube is a polygon made of 4 edges and 4 vertices. A 4-sided polygon is equal to color quad, with a 3-sided polygon called a tri. This hand was made of 350 polygons in total. So not only did they have to graph out every single point on this model, they had to manually measure the X, Y, and Z coordinates of every single vertex of every single polygon. With everything in this process being as manual as it was, it should come as no surprise that rendering the animation into something you could actually watch was manual as well. When I'm done with the video, I go to the render page in DaVinci Resolve, then I hit the render button, and then it renders it. But digital video codecs didn't exist in 1972. Remember, this is back when computers were barely able to display a single static image, let alone real-time playback on a video file. Just getting a look at his imagery was a task in itself, because the display hardware never showed the entire image on screen at any one moment. It took 30 seconds or so to cycle through the image. Campbell could see a frame of his work only by taking a long exposure pull of the screen and looking at the snapshot. Once he was satisfied, he then shot the footage using a 35mm movie camera that the department had to take pictures of a CRT screen. This passage makes it sound easier than it actually was. I've been digging around through research papers to try and find exactly how this photography rig was set up, and they all gloss over that particular detail. But to put it into perspective, each frame of this animation took about 30 seconds to display on the computer screen, because the computer only had enough memory to show a sliver of it. This means that in order to see a single frame of animation, a rolling slice of the image was slowly displayed over the course of 30 seconds, and long exposure photo was required to see the entire frame all at once. They couldn't just hit play and turn the camera on to record it. They had to wait for every frame to be fully exposed before they could move on to the next one. I think it's a bit of an understatement to say that this experiment was ahead of its time. These days, it's like seconds.
So it was quite a pain. And when you were on the bleeding edge, if you go to graduate school and you were working on really difficult problems, this is just how it goes, okay? Every little inch of progress you want to make, you got to fight for tooth and nail. And it can be very slow and very arduous and very ambiguous process. That's what makes research and the life of a PhD student so difficult, okay? By the way, that name Ed Catmull came up a few times, right? Have you ever, does that ring a bell to anyone? Because let me see here. If I go to my modifier and I add a subdivision surface, do you see, oh, what is that? Catmull Clark, right there. So the team, right, these people, you're going to start seeing them again and again and again. Do you know who founded Pixar? It was that guy, right? Co-founded it. Catmull did. And so, yeah, it is, especially in the early goings of a new field, it's a very, very small world, okay? And you keep seeing the same names come up again and again and again, okay? So we really should appreciate how good we have it. But things were difficult back then too, and today they are difficult for us as well, just in a different way. So Ed Catmull, right, is just fighting tooth and nail to even get a single image to render on his computer screen. But you know what he doesn't have to fight? He does have to fight his computer. He doesn't have to fight any competition at all. There's no competition. If he solves this problem, he owns the market, okay? So you have the opposite problem. The tools we have today are just amazing, okay? It's never been a better time to start learning 3D modeling, and that's a great thing. Also a very difficult thing because, as you've seen, there's so much competition, it is overflowing, okay? A river of competition you have to deal with, then somehow distinguish yourself from if you want to have an impact or make a career out of it, okay? So they had problems and you have problems, and they're kind of opposite problems, but hey, everyone has problems, okay? All right, so a quick funny thing I saw on the Blender subreddit. So, yeah, this is a artist saying why I never send my work in progresses to a client. I've never used the kind of hair and the specific fur based technologies that Blender offers. But apparently, a lot happens in the render that does not happen in the kind of normal default viewport mode, the material preview mode that we're always using, okay? Which I thought was kind of cool. This course will not be getting into this topic, okay? In fact, you've probably noticed there are a ton of topics that this course just, we don't have time to cover, okay? The feedback is flowing in from the assignments. Austin, you got to cut this down. It's too overflowing as it is, okay? And so the main goal of this class, if you think about it, is mainly to kind of get you interested in the topic and enough basics for you to kind of start exploring for yourself, okay? And if you want to become a legendary 3D artist, that's what you have to do, okay? You have to find a way to go home and still love this topic, love it enough to explore and experiment yourself, making models on occasion and trying out new things like fur technology and stuff like that, okay? So, yeah, pretty cool stuff. And joining a subreddit like the Blender subreddit, not a bad idea for keeping yourself inspired and learning new things pretty often, okay? Historically, Blender is open source. You saw this in a previous video, but I found another very short video that goes into a little bit more detail and even has a little bit of interview with the creator of Blender. And so I wanted to show that to you really quickly, okay?
People don't know this, but Blender wasn't always open.
too quiet for some reason. Yeah, maybe. No, it looks like it's maximum. Yeah, we'll see. Oh, yeah, I did, yes.
In 1998, Blender was released to the public. A lot of people don't know this, but Blender wasn't always open source. In 1998, Blender was released to the public as a freemium product, with some features requiring you to purchase a serial key in order to use them. And it was a fully commercial enterprise. It had $5.5 million in VC funding. It had 50 employees. They had a booth advertising themselves at SIGGRAPH. It was pretty similar, I guess, to an Autodesk of today, except that in 2002, the dot-com bubble burst and then Blender ran out of money. And that would have been the end of the story, except that the founder, Ton Roosendahl, decided to buy Blender back from the investors. So he started a crowdfunding campaign, raised 110,000 euros, bought Blender back, and then released it open source for free. And he did that because
I was never interested in money. Money doesn't mean anything. It's not interesting.
a lot of people don't know this, but Blender wasn't all.
It's pretty cool to see, isn't it? A very rare philosophy, and Blender has a very rare history. I think that's part of what endears this technology to so many people and to so many artists. So, yeah, good on Mr. Rosendahl for doing that. Okay, older games had some really cool optimization techniques. We talk about how important it is to try and keep your vertex count low. You want to keep your geometry as simple as possible, and often we use things like textures to get more detail and more visual spice while keeping our geometry the same, or keeping it as simple as possible. But there are other techniques that you'll see in a lot of games, and in particular, I want to show you some from some 3D Sonic games, okay? And I'm going to show you these two clips, and I want you to look really carefully and see if you notice anything interesting, okay? Okay, ready? Here's the first one. Do you notice anything interesting about maybe one of the objects in this video? And I'll play it a second time, just so you can watch carefully. There's one object in this video that should be extremely high vertex count, just based on looking at it. I'm going to show you another video. It's kind of I think another angle. Let's take a look. This one's a very short video, but it's kind of cool. You can see it doing some interesting things. So what object am I talking about that should cause our Dreamcast game console to start smoking, okay? Yes?
Is it the ring on top of the head?
Bingo, it's this right here, the ring, right? The torus. And it looks, look at how smooth it looks, right? The shading is super smooth. This looks like it is just very, very high poly, high vertex count, right? It's going to blow out the entire vertex count budget, okay? The graphics card inside the Dreamcast is red hot, okay? But if you look at this, actually, I want you to tell me right now, I want you to tell me how many vertices does this actually probably have? Because this ain't a torus, is it? How many? Why 4? 4 vertices for this smooth object?
Because it's just a flat plane.
Yeah.
It's just a quad. Exactly. Exactly. Fantastic. So this is a fake image, okay? This is a texture on a quad, okay? The material is supporting transparency, and this texture has been pre-rendered. This object does exist in a 3D modeling program somewhere at Sega's office, but it's not an object that exists in real time. It is a texture that has been pre-made. Okay, renders have been taken, and now those renders are part of a texture sheet that gets slapped onto a quad at runtime. So we have a quad up here that is pretending to be this beautiful shape. And when the camera is zoomed out, because that halo is not super big, right? It's kind of a small thing, right? Can you tell? Can you tell it's fake? when you're zoomed out, the camera's way out here, the halo's small, you can't tell the difference at all. In fact, if you go back and play a lot of games and old games, a lot of them did this. If you look carefully, like Mario 64, famous game. Should we look at it real quick? We're going to see it. Mario 64 gameplay, no commentary. Okay? Let's see. Here we go. Look at the coins before we collect them. Okay? Look at these coins.
Oh, yeah.
Can we see some coins? Okay, look at, oh, we're going the wrong way. Oh, that's 3D. Damn. Just when I want a coin, they're all gone. There you go. This coin right here, is this a 3D mesh? Yeah, it was at one point.
Yeah.
Okay, this is not a 3D mesh. This is a handful of textures that are getting swapped. The texture is what's animated, not the actual coin. This is just a quad. And this quad is programmed so that as the camera moves, the quad will rotate itself to always be facing the camera. This is called a billboarding technique, okay? And it's a great idea, okay? Very, very good idea, especially when you're on this weaker hardware that can only handle so many polygons, okay? And so, there you go. You can't even tell, and it looks great pretty much everywhere, okay? So, good stuff. Anyway, this is the kind of stuff that really matters, okay? This is what separates a hobbyist artist from an industrial artist. The industrial, employed, hired artist is always thinking about their teammates, is always thinking about the larger project, the larger product, the game, the technology, okay? Remember, you're a tech artist. You love the art, but you also really dig this technology, right? And how it works and what it needs. And if you want to be a good teammate, the kind of teammate that someone's going to hire, then you want to try and keep your models as efficient as possible. You want to do the best job you can with the minimal amount of resources, okay? Because that frees up resources for the rest of your team to do other cool stuff, all right? So anyway, very good stuff, very fun. So this is going to be a very short lecture, but what I wanted to do is I wanted to show you a few common problems that arise when you are dealing with these rigs, okay? Savannah XYZ said the rigs were a nightmare. I said they were easy on Monday, and then I kind of had to eat my words, right? Because a few things actually went wrong during that Monday lecture, okay? And one of them is that when I had finished with my worm, okay, when I had finished building the armature and adding an IK constraint, so I could grab the end bone and kind of move it around, it was just so nice to do the poses and create the keyframes. The keyframes were failing, okay? They were not storing and copying and duplicating the way that I thought they should. Well, the reason I think is very technical, but basically the way that an IK constraint works is that it's kind of driving not the entire skeleton, but just that end point of the skeleton. And so if you are making keyframes, sometimes it keyframes the wrong thing and you get a really unexpected result. Okay? What am I saying? Well, here's what matters. Okay? In your homework, you are going to use some IK constraints. In fact, on the first problem, you can use an IK constraint if you know about it. The problem won't teach you about it. You don't need it, but it's pretty useful to use it if you think about it. So let me show you this real quick. I'm going to show you what the standard practice is, because I kind of took a shortcut I shouldn't have. Okay, what I'm going to do is I'm going to go create that armature. I just did it. I'm going to go to my little green icon, and I got to always make sure it's in front. I can't believe that's not a default. Okay, and I'm going to go in, and I'm going to go ahead and edit that armature. I'm going to go ahead and hold a control as I do so. Extrude control. I can bring it up really nice and quickly. Keep it pretty much consistent all the way up. Okay? And I'm going to bring it all the way to the top. My geometry is now finished. I could bind it now, but if I do, we're going to have some issues when we go and make that IK constraint, which makes the posing so nice. Here's what you do, okay? We've got these bones that are meant to deform this mesh, but there's a thing in armature design called a control bone. This is a bone, a special bone. It's not meant to deform any geometry. It's meant to control and drive other bones. Okay? And so, here's what I'm going to do. I'm going to go back into edit mode. I'm going to say, I want one more bone. I'm going to Shift D and duplicate this one on the end upward. Shift D, duplicate it up, kind of like this, okay? Now, if you look carefully, there's a little dot right here that suggests there's a parent connection. You can see this line, right? This kind of faint line. I don't really want that, okay? Could cause some issues later, so I'm going to go Alt-P. I want that parenting to go away, and I clear the parenting, and now the line is gone. We just got a free bone here, okay? So now I can add my IK constraint to this end bone. I'm going to go to my little bone, I'm going to go to pose mode. So pose mode is where you can deal with these kind of bone-specific constraints. Going to go to bone constraints, add bone constraint. I'm going to go to inverse kinematics, just everything is normal. But what I'm going to do is I'm going to click on this and I'm going to say what my target is, okay? This armature is our target. This is what will be deformed by this constraint. And then I can choose what bone I want to be my control bone. And I can choose this crazy bone out here. Your end bone will turn yellow instead of turning that kind of brown is what it turned into last time. And now you can right away see the magic, okay? We can now manipulate this end bone, and as we do, the rest of the armature will try and reach out to grab it. If we reach out too far, it'll be super stiff, right? But if we bring it back in, it will start to bend in the way that we desire, okay? Isn't that cool? Looks like we could make the worm dance or something, right? And so, that's great. Now I can go back to object mode. I can do my parenting. I want to parent this geometry to this armature, Control P, and with automatic weights, boom, just like that. I can now pose my armature how I want using IK by using this kind of end bone, this control bone, okay? I'm going to go ahead and bring it down. Actually, you know what? No, I'm going to leave it up for my first little keyframe. Move it a tiny bit, turn on auto keyframing, gonna move it a little bit, we got a keyframe. Gonna go to 20, I'm gonna bring it down like this, okay, kind of looking forward like that. How about 40? Okay, 40, I think I want to kind of like that, look off to the side, kind of look around, okay? And then I want it to look the other way, okay? I want to look the other way. And then at the very end, I want to go back to the original keyframe, copy that keyframe, paste it, it shows up right back here, and look at that. We're back at that original keyframe. I can press spacebar. I'm going to cap this though. End auto keyframe, going to go to 80, and I'm going to just press space, and we can watch this play out. Look at this is exactly how we wanted it to look last time, okay? Now it's nice and smooth. It goes back to its starting position. It's great. But I want to make this more cartoony. And one way we can do that is by giving a little bit of time for the viewer to enjoy these different poses, okay? So I'm going to take this first pose, actually not the first one, I'm going to take the second pose. And I'm going to say, you know what, you should hang out in this pose right here for like 10 frames. I'm going to come up here, I'm going to copy that, I'm going to paste it. So now we've got this 10 frame from frame 20 to 30 where we're just on the same keyframe. Okay, and we're just chilling there. I'm going to do the same thing with this pose where we're kind of looking off to our right. Okay, I'm going to put that on frame 50, copy paste. Going to do the same thing over here, and there we go. Let's go ahead and turn the armature off, and let's kind of watch it play out here. Okay, so I'm kind of looking up. Huh? Oh, huh? Oh, what? Huh? Huh? Oh. Okay, hey, it helps if you add sound effects, all right? I think next week I'm working up a problem where you're going to do an animation. In fact, actually, you've already done a part of this problem in homework 4 if you've gotten to one of the problems. But the problem with homework 4 is that there's no music and there's no motion. So you can guess what problem you're going to be extending on homework 5. But anyway, yeah, adding some audio is something you'll learn how to do pretty quickly. Isn't this awesome? This is so charming. It's like it's just a gray cube. right? But like, if you saw this character in a game, like, I don't know. I think that'd be awesome. So anyway, motion is so very important. I hope you look forward to it. I hope you're super hungry to start animating these cool poses that you're doing, okay? All right, so what else? What else? Well, I want to show you something else that can go wrong, okay? Here's something that can definitely go wrong. All right, let's say you've built up, you've spent so much work. You've spent so much work on this really nice armature. You got everything aligned just perfectly, okay? Just perfectly. And we're going to go, and finally it's time. I'm going to bind this geometry. I've got two objects. I've got Mario's face and I've got Mario's body. These are two different objects. We're going to parent them both at the same time to this armature, okay? Well, actually, I'm going to do it one at a time. So I'm going to bind the face to the armature. I click the face object. I shift-click the armature, Control P with automatic weights, please. Thank you. And oh my goodness, what happened? When you go to do this, okay, I'm going to add the body. So click on the body object, shift-click on the armature with automatic weights. Okay, we're good, right? You're going to go in and you're going to start manipulating the bones and uh-oh, what happened? Uh-oh, what happened? So what happened? Maybe you've gotten to this problem already. It's kind of toward the end of the assignment. I think maybe one or two of you have. What happened was the bind failed, okay? The bind failed and we didn't notice, all right? When something fails or doesn't have the result you expect, Blender's very bad at letting you know, okay? So watch the bottom of our screen here. I'm going to do that bind, the body to the armature. Ready? 3, 2, 1, bind. Do you see this? Not very easy to notice. It says bone heat weighting. Failed to... Shit, I didn't read it fast enough. Okay. Oh, did that one? Oh, that one bound fine. What? Why did it bind okay like the second time I did it? Okay. Failed to find a solution for one or more bones, okay? So basically, it mentions bones, it mentions weighting, it mentions trying to find a solution. Our algorithm for automatic bone binding has failed, okay? And the reason it has failed in this case, and it's a very common reason, is that we have a lot of overlapping geometry that the algorithm is just getting freaked out by, okay? I wish I could offer a more in-depth and technical explanation, but I haven't seen the source code, so I can't really do that. But the problem here is that this mesh may look amazing, and it does, but there's actually a lot of duplicate geometry hidden in this mesh. This mesh, actually, it's kind of nasty, okay? Here's what we have to do. Control-Z, Control-Z. We did the parenting. It's just the weight paintings that failed to automatically generate. So here's what we're going to do. We're going to go into Mario's object here. We're going to go into edit mode. I'm in vertex mode. I'm going to grab all the vertices by pressing A, just like that. Now, I'm going to go to mesh, and there's this awesome menu called clean up. Okay, and one of the really nice options in here is merge by distance. You've seen the merge tools before when you kind of hooked up the various limbs of Stitch, right? Do you remember when you did that? Merge by distance will look at all the geometry you have selected, and it will say, hey, if I've got several vertices that are really close to each other, I mean really close, we will merge them into one vertice. Okay, one vertex. And this is a really good way of often kind of cleaning up geometry and getting rid of useless stuff. Okay, so I'm going to click this and watch what happens. Watch what we see on the bottom when I click this. You won't believe it. Okay, click merge by distance. Removed 396 vertices. There were almost 400 vertices that you didn't even know were in this model. And I'm not sure why they're in this model, but they're here, they're messing up our armature bind. And so now that they're gone, let's have another shot at it, okay? Click on the body object, shift click, okay? Let's parent to that armature and easy. Okay, fixed, good, all right? Sometimes it is this easy and sometimes the real solution is to go find a better mesh, okay? When you get to, I think the penultimate, I think question 12 of this homework is actually, it's called Fan Gamer. And you need to go online and find a model of someone else's IP. It could be Mario, it could be anyone you want. And you're going to rig it up with your own armature, and you're going to give it 3 poses, or maybe more like 4 or 5. And anyway, you might find some meshes where it's just almost impossible to get it cleaned up enough so that the armature works well with it, okay? You can paint each bone's influence manually with weight painting. You do not want to do this. A huge nightmare. In the professional realms, I think you often have to do this because your characters are so complex and so detailed, and they've got limbs everywhere, they've got cloth and clothing everywhere. But that's why it's a full-time job, like being a rig artist. In the industry, there are people who all they do is deal with armatures and getting characters to respond and react properly. And then they hand their work off to the animator, who then has to use their work to create the cool animations. In any case, we've solved that problem, but actually, have we? Because I want Mario to jump. That's what he does, right? And so I go to give him the jumping pose, and uh-oh. Do you see it? Rest in peace, okay? This is going to look awful, all right? If I have him do like a splits jump, then it really shows how bad it is, okay? Look at this. My problem here is that I bound, okay? I did the armature bind with automatic weights, and this geometry next to Mario's heel was close to multiple bones. It was close to these bones in Mario's shoe, but it was also close to his root bone at kind of the base of the entire model. Okay, so we have this big problem now. Well, what I want to do is first, and I see a lot of you not doing this, okay? First, I need to get close and I need to really look at things well, okay, from close up. So if you are trying to use a laptop trackpad to like, oh, I'm going to get in here very closely and oh gosh, right? How many of you do this? I see you doing this all the time. You're trying to get the perfect camera angle. So you're using shift and you're like zooming and I zoomed too much, I'm zoomed too little, right? Use the first person fly mode. It is amazing. With the pinky, shift, and then with your index finger, tilde, shift, tilde. Now I can fly like I'm playing a first person game. And if I'm going too slow, I can use my mouse wheel, scroll it up, let's go faster. But if you want to be precise in really enclosed space like this, you want to scroll it down so you can go really slow as you get close and you can just kind of inch your way in here and really get a good look at what is happening. This is going to be important because I'm going to show you hopefully how to fix this. So let's go ahead and get out of here. Let's go to object mode. The problem lies in the weightings of these vertices to the wrong bone. And so we need to go to the object where the vertices are stored. So this object, we need to go into the weight paint mode. And you can see that bone 39, let's see here. I think what is bone 39? I think it's the shoe here. Yeah, I want to find bone, oh, there we go. The root bone, do you see this green? Okay, I'm gonna go shift tilde so I can kind of fly right in here and get a good look. Do you see this shift, this green right here? This is not what we want. We're seeing some greens in here. We're seeing yellows in here. This means that this central bone has a little bit of influence on the inside of Mario's pants, okay? And we want that gone. We want to see dark blue everywhere. Dark blue means no influence, 0 influence on those vertices. Light green means a little bit, okay? Teal means a tiny bit. Red means a ton. So what can we do here? Well, I'm going to fly in, and I think, can I paint? Yes, I can. So I'm going to hold shift. I'm going to hold control. I'm doing the opposite of painting. I'm removing the influence completely. So I'm getting in here and just kind of scrubbing. You see how sometimes I have to scrub a lot to make it go away? That's because I need to hit the vertice like dead on. Okay, I need to hit that vertice right on the vertex. It's a bit hard to see where the vertex is, but here's one right here. Control Shift like that. If you try and paint between vertices, you won't get anything to happen. So you have to kind of find the vertices and get close. That'll help you, and you can kind of scrub a bit, and Blender will start to get the message. And I can fly slowly to the other side where we've still got a little bit of green going on. The right leg is looking pretty good. We're almost done with that one. Oh, oopsie. Control, hold Control, okay? And we're just going in. That looks like pitch, like perfect dark blue, okay? Looking fantastic, okay? I'm going to get in here, just kind of working on this a little bit. And we can test this, and we can come back in if it is not doing what we want to do, okay? This is weight painting. We are painting the influence of our bone on all this geometry, okay? Maybe that, yeah, just a little bit more light blue tint around this leg here. I'm just getting rid of the rest of it. Then I'll fly through one more time really quickly, and maybe there's a little bit more on the front I just want to knock out if I can. And this is looking pretty good, okay? Looking pretty good. Maybe on the bottom of the shoe there could be some influence. Is there? No? Okay. All right. Well, let's, doesn't that look kind of weird? Mario's face, it looks like he's in a costume or something. Blue Man Group or... Yeah. Okay. This reminds me of like a blue version of Domino's Noid character.
Oh my god.
I've been playing a lot of Pizza Tower, so it's just on the mind. So anyway, sorry. Okay. Focus, everyone. Focus. So what I want to do is I want to get out of weight paint mode. I've already told Blender now that I want to change the influence. I've done that. I'm going to go back to pose mode on the armature object, and I can go back to that leg, and here's the moment of truth, okay? We're going to go ahead, and we're just going to kind of bend that leg. I'll get the right camera angle to do it. Look at that. Nice. Rock and roll, okay? Now, I want so this is how you can kind of go in and fix those influence problems, those bone binding problems. Because when you're binding your own armature to these really rich, awesome, complex models, you're going to have this, okay? And in fact, this is one of the problems you have to do in the homework, but I didn't do it all for you because you also have to fix this problem where Mario's ear bone influences hair, okay? Which should not be happening. Okay, that's partially, we can't wiggle the ears in an animation and make this look good because his hair will move and clip through his hat. So you got to kind of fix that yourself. We had a question?
Yeah, I just wanted to say something I found useful, like when you said getting close to stuff. If you're in edit mode and you have a bone selected, you can press tilde+3. And do view selected, and it'll get really close, and you can get that nice orbit camera around when you have selected.
Oh, just the bone? Yeah. Yeah. So let's
vertex or a face, or really anything, like a selection of faces.
Yeah, let's do it. So usually I go up here and I go to view and then frame selected because I don't have a numpad. But tilde. Oh, did you do simulate or did you rebind it? The key.
I just pressed like the squiggly and then 3 on the top of it.
Okay, well, you know what? Let me grab this bone and see if it works. So tilde+3. Ooh. No way.
If you go to...
How do you find this?
I just Googled it.
I Googled for this over the summer 10 times, okay? And I can... okay, anyway. So I want to make sure this works with geometry too, because that's really great. So I want to work on this button. So I'm going to grab that button, some vertices, tilde+3. Oh, yeah.
What I did was emulate numpad, so just use period.
Emulate numpad breaks some other things. And I don't remember what it breaks, but it was important enough that I had written it into my homeworks, and then I went in and I removed it from all the homeworks. Yeah, don't do this. Yeah, this is great. tilde+3, thank you. Well done. Good. Okay, so I want to tell you that we could have avoided this in the first place, though, because do you see this bone? This is another bone that's kind of sort of like a control bone, right? Clearly, it's not really meant to affect the geometry. It's just kind of the root bone for our entire armature. I mean, you might even delete this, okay? But if you have bones that you don't want to influence your weights, then here's what we're going to do. I'm going to actually clear the parent here, and I'm going to rebind. But before I rebind, I'm going to go in to my edit mode. I'm going to click on this bone, and I'm going to go into the bone, the individual bone settings. You see this big checkbox next to deform? By default, and this is a pretty good default, Blender assumes you made a bone, you want it to deform some geometry. Well, you can uncheck this box, and I think, and we'll have to test this real quick. I think what's going to happen is the armature is just going to the geometry is going to ignore that bone in the armature. So let's go ahead and test it. Bingo. Okay? And it just works like that. So sometimes you can save yourself a little bit of work by setting things up properly the first time. Speaking of which, something that I've been very lazy with and that the homeworks are super lazy with is proper naming conventions for your bones, okay? And if there's anything I should probably fix for next semester, or, a year from now when we run this a second time, is forcing you to have good naming conventions in the entire homework. Because currently the homework doesn't make you do that, and I can't put it in midway through the homework. Everyone who's gotten through it will be very salty with me if I do that. So, what am I talking about? Well, unfortunately, this awesome armature, we're going to have to get rid of it, okay? So we got rid of the armature, and I'm going to kind of build my own really quickly. It's not going to be a very good one because I want to save a bit of time here. I mean, not like, we don't have that much else to talk about, actually, but that's okay. I'm going to go and make our armature visible. This is going to kind of be our root bone, so I'm going to go ahead and make sure it does not deform. Let's go into that bone. Let's go to deform, turn that off. I'm going to go ahead and make another bone. Okay, I'm going to bring it up here, right into kind of the belly area. That's fine, looks good. And I'm going to go ahead and I'm going to use symmetry. Okay, notice that just like using the mirror modifier to build geometry for a symmetrical character, we want to use the symmetry of our skeleton as well. You can't really do this with a mirror modifier, though. You can do this in another way, okay? For now, I'm only going to focus on this right side. In fact, Mario's left side, okay, over here. And so what I'm going to do, let's go ahead and create some bones, okay? Going to kind of bring this up like that. I can kind of bring it down the leg. Going to be very sloppy and very fast here. I think the knee is around there. Got like an ankle bone, maybe a bit deeper into the shoe. And then we're going to kind of go to this side and just bring it out. Okay, like that. Okay, good for a few seconds. All right, let's go ahead and bring this up kind of to the torso, neck area, shoulder, kind of elbow, wrist, and then I don't know. We'll just kind of bring this over here. That's good for those fingers, and then maybe we can kind of bring this over here for the thumb, and that's good enough, okay? And maybe I'll bring this one up. This is going to be symmetric, so I'm not that interested in this, actually. I'm going to come in here. I'm going to go ahead and do the nose, right? We need the jiggle physics on the nose. We need some dynamic physics on the nose, right? And so we got to have those bones in the nose. And so I might then bring this up into the hat, okay? And that's it. Maybe I do one more for the cap. Okay, I don't want to bore you. So let's go ahead and bring this in the cap. Okay, wait a second, one more. Okay, down here for like the hair. Okay, that's kind of cool, and you could split it off if you want to. Now, the thing to notice here is that there are certain bones that are symmetric, right? Right, this arm, we would really like to just take what we've done over here and move it to the other side. We would like to take these bones and we would like to just move them to the other side and set things up. We could go in and just kind of try and replicate it and do like this manually and, oh, I'm a little bit different, so that's a bit weird, right? It's a it's kind of boring, right? It's hard to be precise, it's slow, it's boring, it's annoying. Okay, we want to be fast. We only got 20 minutes to make these daily models, okay? Oh, and by the way, I want to show you something real quick, okay? Let me show you something real quick. Daily model. I snuck this in. I wonder if any of you saw it. I don't think I announced it. I snuck it in. I'm always sneaking little things into the various assignments, and sometimes I think someone caught me on video. Okay, I don't know who, I don't remember. Can't find your animations, so your daily models can have animations on Sketchfab, okay? So I uploaded this last night to my Sketchfab, and actually, if you have multiple animations, which next week you definitely will for many of your objects, maybe not your daily models, but you can actually see your list of actions, they're called, down here in this little list. So I've got a look around action, but then I switch to the dance, and now my worm is just kind of like, right? And just dancing, and it's awesome. It's absolutely amazing. So don't be afraid to do small animations for your daily models. Maybe you say, I'm going to have a simpler model, but I'm going to spend that time, that extra time I saved, on an animation for the model. Okay? People will freak out if you do this. It'll be awesome. All right? Anyway, so we're back to Mario, and if I recall, what we need to do is we need to help Blender understand these bones. And one way that Blender understands the bones are through their names. If you click on each bone while we're in edit mode, I think pose mode this would also work, you can see that in the inspector, in the details over here, the properties pane, under bone, we have the name of the bone. We have bone 11. We have bone 13, okay? If you are in a professional setting, you should actually give these a name. So this one would be bone shoulder. This one would be bone elbow. This could be bone wrist, okay? Bone thumb, bone fingers, okay? And you just kind of name them as properly as you can. But what's really important here is this. Are you ready? Dot L. Dot capital L. I don't know if dot lowercase l works. Maybe it does. Maybe we can test it. I don't know. But dot L and dot R are two things you can add to the name of a bone that tell Blender, those things are special, those two characters. They tell Blender that this is a bone that is part of a certain side of a mesh. And that's super important for symmetry, okay? So we could go through, and I might have to if I forget how to do this, we could go through and do dot R on each of these, or dot L, because this is Mario's left side, okay? But actually, I think I want to do this a bit faster, because I think I can click all these bones. Do I have them all? Click. And I think I can go to armature. Names. And then I can go auto, left, right. And look at that. Now all my bones have that little dot L on the bottom, okay, at the back. Now I have to do this for these other bones, and you might be wondering, Austin, why don't you select all these bones and then all these bones? Well, if you try and select these, I'm not sure why Blender does this, but, oh yes, so it loves to grab bones that are in the middle, and you don't want to give like a left or right name to a central non-symmetric bone. So I kind of do them separately, and it seems to work. So I got this leg bone, and then that's going to be it. So let's go back to armature, let's go to names, let's go to auto, left, right. Boom, they got those dot L bones right there. So I'm going to go back to our arm, click, and then I'm going to go right-click and symmetrize. And boom, notice that not only has the skeleton been perfectly recreated with all of the parenting and child relationships, but also it knew, it was smart enough to name it with the dot R. Okay, so the name has been changed. The dot L has become a dot R. I'm just going to do the same darn thing with these bones. Okay, and I think I have them all selected. Right, symmetrize, and then with just a few clicks, we got the full mesh done. Okay? All right. So, you know why the videos you record, these videos, let's see here, right here. Do you know why these videos are called process videos? Process means kind of a particular thing in 3D modeling because two 3D artists can arrive at the exact same final model. But if one gets there in 10 minutes and the other needs 2 hours, that is a huge difference in process. And usually if you watch pros, what you'll find is that the pros, you can barely keep up with them. They're using a hotkey every second. And they are taking every shortcut in the book. They're using things like symmetry in their meshes to move at the speed of light. And a beginner, okay, a student possibly, me, does almost none of this. Which is why, right, our modeling, especially my modeling, is super slow, okay? And so when it comes to, again, when it comes to going from a hobbyist 3D artist to an industrial 3D artist, working on a big team with a big budget on a big film, right, Pixar film, you need to be using hotkeys. You need to be using all the properties of a mesh that you can to speed yourself up, okay? That is having a good, fast process, and that really matters, okay? Time is money, and you know, if you are going to pay $100 over the next hour to a beginner artist and an expert artist, that expert artist can produce maybe 2 or 3 simple environmental objects that look good. The student artist might only get 1 or might not even get done, might need a second hour, okay? So you want to, you want to have a good process, okay? And if you ever find that, wow, I got some classmates that are just doing really cool stuff, and I can't believe they did this in only 20 minutes, right? 30 minutes. Go watch their hotkeys, okay? Go watch their techniques, and that will give you a strong hint as to how they can move so fast. But another part of that, it's not always process. A good part of it is being able to plan all this out in your head, either beforehand or as you're going, okay? This thing happens when you're a programmer. Okay, where are my programmers at? My engineers? Okay? There's this thing that happens to a programmer where when they're first learning how to program, they move super slow. They have to spend an hour planning out what they want to do. And then once they get into it, they have to keep planning, and they're very slow at that. They have to take a break. Eventually, after 4 or 5 years of programming, and sometimes it takes a bit longer, no worries, you eventually get to the point where an experienced programmer is thinking about what they want to do next while they are typing the previous line. Their brain is no longer the bottleneck, their fingers, their typing speed is the bottleneck, okay? And they can move super fast. They are, as we would say in aviation, they are way ahead of the plane, okay? They are way ahead of the game. They are ahead of schedule. They are thinking 5 steps in the future, okay? So this is all to say, eventually you'll get to that point in programming if you're a programmer, but if you keep making 3D models and keep pushing yourself and watching other people and trying to experiment with new techniques and new ways to do things, a new process, eventually you'll get to that point as well, okay? Where instead of 50% of your brain just trying to remember the hotkeys, you're spending 1% of your brain doing the thing, and 99% of your brain can be thinking about the next 3 or 4 steps, or about the art style, about taste, okay? About really, really difficult artistic topics, instead of how to do the thing in the blender, okay? So you'll get there, all right? Just a matter of time and friction, okay? Whenever you're learning something new, the friction level is always through the roof, okay? But the skill curve, the friction curve, right, starts to kind of go exponential, starts to go like that, okay? Because if you can make it through the first couple months of any new topic, the friction starts to get melted away. You're moving fast, and as a result of moving fast, you have more fun. You're enjoying it more. You get more done. That means you're learning faster. You're doing it more often. You might even start making some money. One of the best things, I think, for an artist or a programmer is to get that first gig that pays you. Because now you can justify being in your tools and learning for not a couple hours a day just for fun, but for 8 hours a day as your job. Okay? That is a massive difference. All right? And you'll learn really fast. Okay, anyway, that's the end of my rant here. I think I've got an extra 30 minutes. And so, those are what I wanted to tell you about. All of these little gotchas with the armature system, right? They're going to blow you up a few times. Don't worry. But every time you get blown up, they'll cement in your memory, and you will not have to deal with that in the future, probably. Okay? So, I think that is pretty much all I wanted to tell you about. We solved some of our issues from Monday. Next semester, I'll probably have more of a full lecture here. And next week, we actually have some really great lectures for you from Evan Marcus, who's done a few of your problems. He actually made the Han Solo and Roblox problems on the last homework, okay? Which maybe he didn't have quite as much time as I did, but they're really big and ambitious problems. So really cool stuff. Anyway, he's a much better animator than I am, and so thank goodness he will be helping us think about animation, think about shape keys, think about the crazy nonlinear animation editor, the NLA. Okay. That thing strikes fear into the hearts of student animators, okay? And it's quite gnarly, but it is so cool and powerful. And that's what we're going to do next week. I hope you're looking forward to it, okay? I hope the current assignment is going well. Seems to be. I think we got a couple of students who got through it already. So maybe it's an easy one, okay? Let me know if you ever want more problems, okay? And want the homework to be longer. I can go in and I can make them longer. Okay. Everyone, I encourage you to take the remaining 30 minutes, knock out today's model of the day. It is a toothbrush. People were memeing about how the toothbrush was going to be like a billion polygons because all the bristles, right? I would actually challenge you to make like an N64, a PlayStation 1 era toothbrush. You know that thing is just going to be a cube. It's going to be like a long cube for the base, the brush, and then the actual thistles will be the smaller cube. And then the challenge becomes, how can you work the textures to make that look really good still with like 20 triangles, okay, with like 20 vertices. Okay, that's probably what I would try. Anyway, you can do whatever you want, all right? And I wish you luck. Until 4:30, we have office hours, okay? At 3 o'clock in 30 minutes, we might have a bunch of people pour into the room. I will probably be hanging at the back of the room or through those double doors if you need me. And thanks for coming to this short lecture, okay? I will see you next time. Have a good weekend. And go blue. All right. Everyone online, I will see you later, okay? Bye-bye.